Good morning. Today, our lecture topic will be continuing the content on how we create scientific article. But in last Thursday, we talked about on how we make the paragraph or how we outline our sections, headings, and then the writings of the paragraph that is related to each section of the article. But now we are more put our attention to how we produce good table, graph, and basically all of the graphical illustration that we want to add in an article or in a presentation. But before that, I would like to inform the students here. Let me see. About the current situation in campus, due to the fact that the number of people who get infected by COVID-19 is getting increased day by day. So I am thinking that as probably you all knew from the current update or the current news from ITB, that telling us to keep away from campus and work on online meetings or online lectures more often for the next 8 days. And then if there are classes who have practical experience in the laboratory, the arrangement of students who are coming to campus will be limited to 50% from the total capacity, okay, of the respected room. And then the defense or thesis seminar or group discussion or even a final project discussion are required to be online for the next 8 days from February the 7th until February the 14th. So from Monday to Monday. And then it will be, and then this information will be updated every week corresponding to the situation that the city of Bandung or the county of Jatinangor has, so that if the class need to be shut in the campus and move back to online, it will be the best option for this week. And then there are also requirement for the workers, which also includes lecturers to work from home. And then if they have a requirement to work from office, then there are minimum requirements or number of people who can enter the room. And therefore, for students, if you also have necessity for collecting data in the laboratory, you should inform the administrator in the physics department or in the laboratory administrator, which later on will inform the people in the physics department about how many people who are going to work on that respective laboratory. Okay, and then for those of you who haven't got vaccinated yet, please do so, because there will be some kind of a requirement. Okay, there will be some kind of a requirement to have 2 doses of vaccination, especially for those who are coming out from outside of Bandung. And if you are traveling in some days, if you are coming from outside of Bandung and then doesn't have any time for self-quarantine for at least 5 days, you need to include the antigen test to be completed so that you can enter the campus. And then I guess the rest of the information here are mostly related to the work to the employees, which includes the dean, and then the member of faculties, and then the officer of the faculties. Not so much as students, except regarding your attendance for your offline classes, laboratory practice, your defense, final project defense, and working in the laboratory. Okay, these are the current information that I need to share before we moving on to our class topic. Okay, so that everybody in this class, especially who are coming from physics department of ITB, knew about the current situation on the campus, so that they will not be surprised when there's some kind of a stricter test or stricter regulation when they're going to enter ITB on 7 days on 8 to 7 days to come. Okay, we already talked about standards of scientific paper, scientific words, sentences, paragraph, and writing scientific text. Now we are talking about presenting numerical data, constructing scientific figures, writing, and research paper. Okay, so presenting experimental procedure and data, we describe the experimental or theoretical technique and method with enough detail to allow other researcher. Illustrate. So the illustration is created basically to help readers, which also includes the fellow researcher who want to replicate our work, so that we can have some kind of a secondary confirmation about our method, or we're going to have some kind of a validation from people who are also working in the field. Okay, so the description, okay, the accurate and detailed description on the theoretical and experimental schematics on our paper is done so that the reader will have enough detail to repeat our measurements and then to evaluate our method. Because in terms of communications, in terms of the communication between researcher, in terms of their research finding, people or scientific community will evaluate whether our technique is a correct one, or do we have some kind of a gap, or do we have some kind of things that need to be elaborate more that we didn't do in our experiment. So when we remember, if we remember when we talk about research gap in the beginning of our semester, the gap that is created is not deliberately done, but sometimes we need to have assumptions or simplification in the experiment, because we cannot hold all of the elements, or we could not hold of the variables when we conduct some experiments, because we need to have some kind of a simplification and assumption, and we make some variables become constant, for example, and then we maintain, for example, the experiments is conducted on STP condition, or etc. and so on. And so it may not reflect the true conditions, okay? Because if we conduct experiment in STP condition, we must maintain the pressure and temperature remain constant throughout the time. However, in reality, when the heat is increasing from morning to the afternoon, and then decreasing from the afternoon until the evening, the amount of pressure is also changing. So therefore, the gap that is mentioned earlier also present there due to the fact that the experiment is not handling the variability of temperature and time, for example. So it means that from the illustration and also the explanation, the description that we present in the article or in the presentation, people will know that, oh, okay, so there are some kind of restrictions, or there's some kind of a limitation in the study, and then so I will fill the gap in order to extend or to make sure that if we have this variability, the relation that these people have is also exists in another experiment, for one example. Okay, and so it is important to use appropriate detail, provide enough detail so that other can replicate the experiment, and then the use of diagram and figures is to help the reader understand what you're doing by using diagram, figures, photograph, flowchart, etc., and so on. Okay, so types of figures that we usually have in our articles, presentations, and also in your final project report. One type is a figure that show process, the process of particle collision, the process of for example, absorption or interferometry, etc., and so on. And then figure that shows data, and this is a time series of I don't really sure what delta G over G here. So it's some kind of a dimensionless quantity that is presented in percentage over time. But sometimes for example, if we deal with seismic data or magnetotelluric data or interferometry data, sometimes we have a raw data that consists of time series like this, which basically tells us about how one variable is changing over time. And then it doesn't need to be some kind of a physical data. Sometimes it can be related to changes of demography over time, number of people over time, or related to number of one organism over time, and it could be also the number of pollutant over time, etc., and so on. And that is basically what the data that we're going to evaluate on the research. Okay, and then we also have figures that show equipment, samples, and illustration, especially in the methodology section. When we tell the readers that we're using this equipment and that equipment, etc., and so on, and the figures that also show how things work. the common thing that we have from these types of figures is that you must maintain or you must produce a good quality figure for your paper, for your article, for your presentation. Because if you lost the good resolution for your figure, it means that it will make confusion among the readers whether the data is taken properly or not, or it's just bad. It's just a bad produced figure that you should revise before you put the respected figures inside of the article or in the presentation. So whenever you have an article that need to write, or you have a presentation that you need to give, it is better for you to produce good quality figures, and then you may study type of figures that are available in the editing process, for example, because there are two types of figures that we can modify. First is the raster type figures, and then the second one is the non-raster, or sometimes we call also as a vector figures. The raster figure, if I'm not mistaken, consists of JPEG, bitmap, and then TIFF images, whereas for the non-raster figure, it's basically a figure that is described by its coordinates. So it's basically becomes a vector figure that you need to edit or you need to produce in another software. So if you have raster images such as BMP or JPEG, it means you can use Microsoft Paint, which is the most basic tools that you can have for image editing, and also the most sophisticated, and then one of the sophisticated software that you can use for raster image editing is Adobe Photoshop or CorelDRAW. If I'm not mistaken, no, it's not CorelDRAW, because CorelDRAW is for vector. But the one that people usually use is if it's not Microsoft Paint or Adobe Photoshop. Okay, Adobe Photoshop and other software that is used for raster image editing. However, for the other type of figure, which is a vector-based figure, which you can save it as an EPS or a PDF format. Usually you use CorelDRAW or Adobe Illustrator, and then in the vector image, the dots or the pixels that is produced there have their own identity in terms of their locations, etc., and so on. So whenever you want to increase or decrease the resolution of the figure, the quality will be maintained as long as you're not stretching it too much, because there is an option in CorelDRAW and Adobe Illustrator, if I'm not mistaken, but how to maintain the resolution whenever you want to decrease or increase the size of the figure. And then we could also add letters, okay, at letters, line, etc., and so on, so that it will complement the original figure with the additional information that we want to add inside of the illustration. But it doesn't mean that you could falsify data with that image editing software. So what I'm with so the purpose of using the image editing software that I mentioned earlier is only to give detail or more detailed information on the image, on the illustration, and that is the only purpose. So that if you want to emphasize a part of the some part of the information that is given in the illustration, the software will make so. The software will help you to have that purpose. However, even though the editing software can erase some part of the figure, it doesn't mean that you need to erase it to falsify the data or to make your hypothesis in line with your data. Okay, so make sure that your data is so as long as your data is considered as the true data, or the data that you consider is already free from noises or free from the unrequired data, and you make sure that your data is the thing that you honestly get from the measurements, and it is free from some kind of outliers that may hinder your conclusions, it means that you could use the software editing to remove that outliers, but not to falsify the data. Okay, so if you falsify the data and then later on people who will recreate your experiments found that you are falsifying the data, then your credibility will be lost. Okay, so make sure you don't falsify the data. Use the software, whether it's a raster image editor or a non-raster image editor, as a tool to produce a high quality data without losing any data itself, without removing the data as well. Okay, so make sure you don't use it for unethical misconduct. Okay. Okay, so these are figures that show equipment, and these are figures that show how things work, and then these are figures that show scale. Okay, so this is a illustration of a airborne map from the border of Switzerland and France, where the particle accelerator's turn is located. Okay, and this basically gave us about the location and also the scale of the particle accelerator itself, where the particle collision experiments is conducted in the area. Okay, so after we show illustration for figures, we moving on to tables. Okay, so in articles, besides showing the reader of certain figures, we also describe. We can also describe our data in terms of table, and here is an example of reactor power level in Chernobyl accidents, which is taken from Wolfson 1991, and then these are the simplified diagram of nuclear reactor from the same author, which I assume this is the one that Chernobyl also has at that time. And we can see here, as the time progressed from 1 a.m. until 1:30 p.m., the amount of power level is decreased. Okay, is decreasing at some point. Okay, until 1 p.m., the power level is decreased dramatically, okay, or drastically from the magnitudes of thousands of megawatts to 30 megawatts, and then in just less than half an hour, the power level is blew up or increased from 30 megawatt to 2 million megawatt. And so whenever you want to present the information given here related to the Chernobyl accident, for example, like this one, you can present it like this one, and then you describe or you explain the occasions that related to the accident in the paragraph, or you put some small information or little information next to the power level. So here, this is basically the same table. Okay, table 1 and table 2 is basically showing the same information. However, here we put additional information regarding the events instead of presenting them in a paragraph. Okay, so these are an alternative for you to present your data, whether you want to show a whole table without any detailed explanation, or you may put some small phrases or a small sentence inside of the data itself, so that you don't need to explain too much in a paragraph. And another example here is a blood glucose level over time that is shown here, a normal and diabetic patient, okay, which you can also present in a graph. Okay, so here table and figures could show or could tells us about a certain event or a certain occasion or a certain process, and then the usage of table with graph is also can be used for describing a certain process or describing a certain experiment done in two specimen. In this case, we have blood glucose level for normal people, and then the one who have diabetes. Another example here is a computational and experimental temperature for laminar diffusion flame is a line graph. They are common in engineering and science, and also in social science, if I'm not mistaken. It is basically to compare two things. One is, so in physics, we usually have dots or discrete circles to show our data, because data measurement usually done in a discrete way. So even though it's a time series, sometimes we have certain time when we collect data, so that the produced data is going to be discrete like this one. So the experiment itself is presented as a circles, and the number of the circles here is relatively limited. However, this can also we can make some kind of a comparison between the experiment result and the simulation result by putting all of the two information in the same graph. But since the experiment is discrete one, so that the simulation is usually typed or usually displayed as a solid line. Okay, as a solid line, because simulation or even though numerical simulation itself is numeric, and by design is actually also a discrete process. However, when we're going to compare the two data from experiment and simulation, we usually consider the simulation result as the one that is going to be continuous, or usually displayed using a continuous line instead of the data that's gathered from experiments. It is regarded as a discrete data, so that the display will be using the small circles or small dots, etc., and so on. But in other case, we also could have a complex graph which contain more than two information. So if we compare measurement from rock sample A, B, C, D, E, F, G, it means that, and also plus the simulation, and therefore we need to have more object or more form or styles that we could have in the displaying of the graph itself. So maybe you could use stars, maybe you could use squares, or maybe you could use triangles, solid triangles, or blank triangles, or a dash line, fine dash line, etc. and so on. But the thing that we need to avoid is obviously to produce a poor data that we usually taken for granted after we produce it on a certain software. So this one is obviously, you know, this is a graph that produced from Excel. Okay, so whenever we have a spreadsheet result and then we produce a graph from the spreadsheet software, when we copy and paste it into our articles, into our draft, whether it's in Microsoft Word or in LaTeX, sometimes we're kind of lazy to make some kind of arrangement in the article itself, and so the quality of the graph from the spreadsheet software is not that good. And we can see here the quality of the axis. Okay, the number of the Y and X axis is unclear, and therefore we need to have editing. So this is where illustration editing or image editing becomes important, is to make the numbers that present on the axis, on both axes, becomes clearer, and then we don't need to have too much numbers. For example, here in the y-axis, let me turn on the pointer. So for example, this one, we don't need to include all of the numbers here. We could make some kind of a range, or we can make some kind of interval from, so I guess this one is from minus something until 1. So if we use only the big numbers such as 1.0, 2.0, 0, or minus 1.0, etc., and so on, without using the intermediate numbers, the presentation of the figure will be better compared to this one. And then this legend over here, if we only have one data, okay, if we have one data inside of our graph, it means that we don't need any legend at all. Okay, unless we have, or unless we're going to produce this type of graph which shows a comparison between 2 data, 3 data, 4 data, etc., and so on, then we need to have that legend. The example of this one is given here, where a blank circle is showing us a data collected from experiments, whereas the solid line is showing us the data coming out from simulation. And for this case, since the data itself is only a single variable, okay, it's only a single variable data, we don't need any legend at all. Okay, what we need to do is to make the numbers on the x and y axis clearer, and then we need to inform what are these information in the y axis and the x axis. Okay, the x axis and y axis. Is it a time? Is it some amplitude over time? Is it a dose over a space, or one quantity to other quantity? Okay, so therefore we need to put the title, okay, not the graph title, but the axis title, telling us what is the variables on the y-axis and what are their units, and also the title of the figure itself, if it's necessary, because sometimes because sometimes when we produce this one, okay, so if we take an example of this one, the information given in this figure itself doesn't require any title on top of the figure, because the explanation can be, because the explanation of this figure can be used in the figure information itself. So here, so figure 3 showing us computational and experimental temperature for laminar diffusion flames. So instead of using titles on the top, we could use the explanation of this figure in the figure explanation, like this one. Okay, so the choices of using a title in one figure or in one figure, it depends on the type of article or presentation that you want to produce. Usually for articles, we don't need that titles, because the information related to the figure can be shown in the figure information like this one, okay, or in the paragraph. If you produce a figure that is going to be presented in a slide or in a poster, then you may include titles above the respective figures. Okay, so keep in mind that keep in mind that which is also true for your curriculum vitae. When you're applying for a job, you cannot use the same curriculum vitae or the same cover letter for all companies that you want to apply. And therefore, in terms of preparing a presentation and an article, you could not use the same graph for all purpose, whether it's in for presentation or for articles. What you need to do is to make some kind of adjustment on what type of communication tools that you want to use, whether it's in a presentation or a scientific article. Okay, so usually for scientific article you don't need titles, whereas for presentation you may include titles on top of the figures. Okay, here a better graph, and this are coming from a certain presentation. So you have a heading or a title of this graph, and then conclusion of the graph is also given like this one, and then you have information about the regression line or about the slope of this line, etc., and so on. So it may help the reader understand your data, and this type of display is better suited for one presentation. Okay, and then avoid giving too many information like this one. So make your display becomes concise or simpler for the reader to understand. Okay, so instead of using this schematics, we show too much process over here, and then even in a presentation you may took more than a minute to explain about this, and so modify it into a better display like this one. So we compare this one and this one. This one is better, okay, and then so that the focus of the audience will also depends on the thing that you explain in front of them, instead of reading all the arrows and process that is given here. Okay, but other illustration in terms of graph, there is a bar graph, pie graph, etc., and so on, and then presenting image, photograph, and drawing and diagram. Okay, like this one. And then the main advantage, and then here when we show a photograph in our illustration, the main advantage of photograph is realism, which this one is showing us how the Space Shuttle Challenger explode at some point after taking off from the ground. Okay, these are also an example on how one machine schematics is produced. And then let me see. And here also about the flow of air inside of the machine that also show the schematic of this machine. Okay, scientists often use illustration that are too complex for the text. Make it simpler. Okay, make it simpler. The precision of the illustration should reflect the precision of the text. Like this one is probably have too many text and also have too many information that is shown in this display. So if you're going to present this in front of an audience, make sure that you make it more simpler. Okay. Yeah, this is also illustration is the meshing of word with image. Okay, these are one example on how you present a paragraph and also figures in one slide, etc. and so on. And to conclude, use figure, picture, graph, and schematics to convey more information, but it should be simple and easy to understand and of good quality. One of the good quality figure that I encourage you all to make is like this one. So it's more so the type of this one is a little bit conservative. It doesn't use too many colors, and the information about this figure can be explained in more details in the paragraph, but the figure itself have respected titles. For example, like this one that is shown in the figure captions, like this one, and then it have clear axis numbers, values, and also titles for the axis, and then what are the legends of the given information inside of the graph. Okay, so I think that's all for today's. Thank you for attending today's sessions. Next, okay, in Thursday we will begin the session for. We will begin the time for you to write the introduction section of your article. I will give you the template later on Thursday that you can use, and then the deadline itself for your introduction will be on next Monday. Okay, so based on the course schedule that we have, you need to submit your paper draft until the introduction on next Monday. Okay, if you have questions and comment regarding the paper assignment, you may do so later on Thursday. Okay, I will stop my recording now.